Okay, so what happens to this histogram, this thing when the probability of making a shot changes? We're going to look at this histogram for n equals 8, and when the probability of success is 10%, 20%, 30%, blah, blah, blah. You can do this on your calculator. If you look at the previous video to create the spreadsheet, you can do this, but I'm just going to walk you through what would happen if you looked at these. Okay, I'm not going to show you every single one of these possibilities, but I'm going to give you the general idea of what goes on here. And then number two, what happens as if the probability is fixed instead of changing if the probability is fixed, okay, and then we change n's from 10 to 25 to 50 to etc. Here on the top, our n is fixed and we're changing the probability. So we'll take a look at those graphs and see what happens. So here, when we have the probability of success is 0.1, of course, the probability of having a lower, like 0, 1, 2, 3, etc., the probability of these successes are higher than they would be for making 7 or 8, or 6 or 7 or 8. When you come down to a probability of 0.5, then 4 and 5, 3, 4, and 5 are going to have bigger probabilities because you are centered, more in the center of 8 with the changing probability. And then if the probability is high that you're going to make those shots or whatever it is, then you can see that your distribution tends to be skewed to the lower end with a higher probability for higher makes or more makes. Probably should be saying more successes, which would make more sense. Now, what about if we have a constant p, and that is our probability of success is 0.74, and it is fixed, and now all we're doing is changing the number of trials. As n increases, the mode increases, and the graph increasingly looks more and more bell-shaped. So at first, we're here when we had like 5 trials. Then when we had 10 trials, it starts to appear a little bit more shaped like a bell. And then here with 25 trials, it's even more so. And then with 100, it almost looks perfectly like a normal curve almost. This distribution spreads out and flattens, and it looks more and more symmetric. And this is the critical point, that we can use a normal model for a binomial distribution if NP and NQ are both greater than or equal to 10. So again, this is a distribution with an n of 100, probability of success is 0.3, probability of failure is 0.7. Again, our mean is NP, our standard deviation is the square root of NPQ. All right, so if we have a lot of trials, then we can simply use the normal model to approximate a binomial situation. Remember, normal model is just that. It's an approximation. It is a model, okay, to model successes and failures. And you can say, what is the probability if you do 100 trials or 20 trials or 30 trials or whatever, if the probability of success is 0.72, you can do, if you take the probability of success equals 0.72, then you can take the normal model. If you have 100 trials, then the mean is NP, the standard deviation is the square root of NPQ, and all you have to do is check that NP and NQ are both, sorry about that, let me undo that, is greater than 10 and NQ is greater than 10. So if N is 100, then we know NP is going to be 72, that's greater than 10. NQ is 0.28, that's 28, that's greater than 10. So we can use a normal model to approximate a situation where we have the probability of success is 0.72 and N is 100. And that allows us to use the normal model, which is really, really convenient. When you do your practice problems, you'll see more, and we'll dig more into this. All right, and that's it. Get in there and start doing the practice problems, and you'll get more out of this.